हाँ सर।
Tamjid?
जी सर।
Yeah, where is your doubt? Please tell me.
The potential divider.
Oh, potential divider. Potential divider you also got in current electricity DC circuits, right?
Hmm.
Can you remember that one?
Hmm.
Potential divider means you have like this one, source voltage. Huh?
Hmm.
So this source voltage will be divided into the appliances. It can be resistor, it can be light, or it can be any other device. If they are connected in series, then the source voltage will be divided according to their resistance. And we
Hmm.
have one formula in our DC circuit current electricity topic. We had this formula. Again, we are giving this formula here. Look here. If you want to get the voltage across R2, then you can find it using this formula. R2 by R1 plus R2 multiplied by VN. Okay?
Hmm.
Did you get it before in your school or anywhere you learned? You got this formula before?
No sir.
You should get it. If you are done with DC circuit current electricity, you should get it. If I give you one example, for example, I'm annotating here. The source voltage is 6 volt, okay, and R1 is 2 ohms, and R2 is 1 ohm. Huh? Then what will be the output here? The output you have to calculate using this formula.
That's
So, huh?
2.
So 2 volt, right? So it is called potential divider. Is it clear now?
No sir.
And it can be varied. Like if you, it is variable resistor, right? So if you make it 2 ohms, then the sharing will be 3 volt, right?
Hmm.
If you make it 4 ohms, then it will be 4 volt here, isn't it?
4 volt. हाँ sir. हाँ.
So is it clear now? This is called potential divider. Anything else? Anything more from potential divider? And potential divider has another name, that is potentiometer. Huh? This is potentiometer. If we can vary the resistance, that is called potentiometer. Tamjid, are you there? Hello, Tamjid.
Yes sir. আর sir potentiometer same জিনিস?
Potentiometer, this is potential divider, and if we have variable resistor over there, we can vary the resistance. in the potential divider, that is called potentiometer. Okay,
अच्छा.
is it clear now? Like
Sir, a relay.
sorry,
Relay.
relay. Okay, we should go to relay, right? Relay, 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 relay. Here we go, relay. Huh? Relay, look here. We have here one small circuit. Huh? This one is DC, 12 volt DC. So this circuit is used to operate one bigger circuit with high voltage. Huh? That one you see it's written AC, and look here we have if we pass here direct current here, then there will be electromagnet here. Huh? Electromagnet becomes or behaves like magnet, and then this switch this switch is made from iron, so it will get attracted uh, by this electromagnet, and then the switch will be closed and this circuit will be on. Okay, is it clear? So relays are actually uh, one one small switch or one small circuit is helping to operate a bigger circuit. This arrangement is called relay. Is it clear?
हाँ सर, नीचे N और NC टे की NONC.
That one is more advanced function of relay. I see here normally open, NO, huh? Normally closed. So normally open means normally we get this circuit open. The secondary one we get it open, and using the smaller circuit we close it, we start it. Okay, this is one kind of relay, and another kind is like it is the machine is on working, right? Isn't it?
हाँ.
So if you on this circuit, then what will happen? This circuit will become open. This switch will become open, and the circuit will be off. Is it clear? So sometimes we need it to operate the machine if it is running, right? Or it is working for a long time. Automatically we need to stop the machine. That time we are using relay also. That means it is for starting, it is for stopping the circuit, okay, or stopping the machine. Is it clear now?
हाँ सर.
Okay. So it's written here. Look here. In this relay's natural state, it is in the normally open state. When the coil is energized, the contacts are closed. Then machine starts. Is it clear? And this one in this relay's natural state, it is in the normally closed state. When the coil is energized, the contacts opened and machine is off.
Okay sir.
Okay.
जी सर हाँ okay.
Done.
sir.
Now about the worksheet. Can you go to
স্যার
worksheet now?
হ্যাঁ স্যার স্যার আপনার কি আগের চ্যাপ্টারের নোটস গুলো আছে লাইক 8 9 10 11 12 13
I have some, especially I have waves. Waves I have all the notes. But thermal physics I couldn't prepare it.
ওকে স্যার থার্মাল ফিজিক্স এর থেকে শুধু হিট ক্যাপাসিটি নোটসটা দিলে আমার যথেষ্ট
But I will let you know when we will have revision class after finishing this. Then that time we will go through the learning outcomes. When we will go through the learning outcomes, everything will come. Okay? Is it clear to you?
জি স্যার
So don't worry. Everything will come. Specific latent heat, specific heat capacity, everything will come. Sure. So we can go to the worksheet now, right? Did you try the worksheet?
জি স্যার করছি I tried it
Okay, you tried. That's the most important thing. So you tell me your answer. We did how much? Till 5 we did, right? From 6 we'll discuss today, isn't it? Did you get 6?
6 স্যার 6 তো করি না
So which one you did?
7 করছি
7, okay. 7, what is the answer?
স্যার ডি ঢাকা
Okay. Seven. Okay, you give in 6. You give question mark. Which one you couldn't do? You give the question mark. And we are discussing which you already did. 7 you got Dhaka. It is correct. Then 8.
8 তো কেনিয়া এটার মধ্যে আমার ডাউট ছিল
Okay, doubt. Then question mark. Then 9.
And 9টা 9টা পাইনি
Okay, 9 we couldn't do. So also you did here question mark. Now we discuss 6, 8, 9. Okay. 6, 8, 9. We'll discuss 6. Can you read the question? 6.
LED is connected to a alternating current supply. The LED flashes on and off. What is the direction of the current in the LED when it emits light?
So if it is flashes on, then it emits light, right? That means it's in forward bias. So to understand forward and reverse bias, you have to give here positive and negative. So when it is positive, AC means Once it will be this way plus minus, another time it
পজিটিভ
will be
দিকে হবে না?
plus minus, this way. AC works this way, right?
হ্যাঁ স্যার, কিন্তু এলইডি দুইটা রাইট সাইডেটা প্লাস আর লেফট সাইডেটা মাইনাস হবে না?
LED, LED, you see this one, this line, this line is showing you minus, for diode.
ওকে ওকে ওকে, হ্যাঁ হ্যাঁ।
For diode, this line is minus. Just remember that where you get this line, there is minus.
ওকে,
Clear?
হ্যাঁ স্যার।
So in your worksheet, you hopefully you got printed it, right?
Yes.
So you label the way I labeled. So now
Yes.
it will be forward biased. That means electricity can go only for this, right? And for this one, the upper one, it will be reverse bias. Electricity cannot go. So we got the idea that electricity flows from left to right if it is emitting light. So what should be your answer?
Towards the right.
Towards the right only, right? Towards the right only means B. So your answer is correct. So why you couldn't answer before? You know everything.
Sir, alternating current দেখা ভয় পেয়ে গেছি।
Okay, okay, you got frightened. That's why. Actually, you know, right?
Okay.
Okay. Now it's done. Is it done? The answer is B.
Yes.
Can we go to next one? 8. Yeah, 8 you can do now. Already you got the idea about potential divider, so you can do it. You know about thermistor, right? Try it. Try it. Read the question. Read.
Temperature falls. তার মানে resistance increases. Resistance increase হইলে voltage.
Yeah, if resistance increases here, if resistance increases here, that means a voltage sharing is more here, right? Then voltage sharing will be less here.
Wait, কি? Voltage sharing is more যদি হয়?
Voltage sharing is more in thermistor. You label it. Label here. If temperature falls, then voltage sharing. Then you write resistance is more in thermistor. Then next step you write voltage sharing is more in thermistor. Did you write?
Yes, sir.
Then voltage sharing will be less in resistor. Now you'll get your answer.
Oh, that means voltage decreases.
Yeah, voltmeter reading decreases. If your voltmeter is here across the thermistor, then voltmeter reading will increase. It depends where the voltmeter you connected. Is it clear? Now you connected the voltmeter in a place where the voltmeter reading decreases. But if you connect it across the thermistor, then you'll see it will increase. It is clear now? Is it clear, Samjit?
Yes, sir.
Okay, so what should be your answer? C for correct, huh?
Hmm.
Did you get the notes? All the notes you are writing on your worksheet. Then can you read 9?
The diagram shows the cathode ray tube. The dotted line shows the path of beam of electrons. The beam hits the screen at point X and produces a bright spot. P and Q are horizontal plates at each side of the beam. What change will move the bright spot to a different position on the screen?
Okay. So if you think of this beam of electrons, beam of electron is negatively charged, right? Beam of electron is negatively charged, isn't it? Tamjid?
Sir,
So if beam of electron is negatively charged, if you apply voltage, if you are applying voltage, voltage means one plate will be positive, one plate will be negative. You don't know which one will be positive, which one will be negative. That is not clear to us, or we did not identify that one. But at least we understand if we apply positive and negative anywhere, then what will happen? This beam of electrons will be affected, isn't it? It will be attracted to positive side and it will be repelled by negative side, isn't it?
hmm.
Then it will move, right? The spot will move,
Hmm.
isn't it?
Yeah.
Okay. So is it clear now? What should be the answer?
Hmm.
What should be the answer?
A.
A. So A for appropriate answer, right?
Hmm.
If you decrease the positive voltage of the anode, what will happen? The speed of the electron beam will be decreasing, right? It will
Hmm.
accelerate less. Then increase the positive voltage of the anode, then speed will increase, isn't
Hmm.
it? Then
Hmm.
increase the voltage between the terminals of the cathode, then what will happen? If you increase the voltage between the terminals of the cathode, here is cathode, right? So you will
Hmm.
get more electron flow, isn't it?
Hmm.
Because cathode is the source of electrons here.
Hmm.
Is it clear?
Yes, sir.
So spot will not move or spot will not change its position. Only intensity of the spot will increase or decrease, isn't it? But spot will move if you only apply a voltage between metal plates P and Q. So is it clear now?
Hmm.
Anything more? Done. All the MCQs are done, right?
স্যার 3 এর এমসিকিউ 3 টা এটা আবার বলা যাবে আমি অ্যানসারটা বি না
Sure, sure. Of course, we can next time. Let's go there. 3. Why B? The time base is off, right? They are saying the time base is off, so your time should be 0 here. Time is 0 in the middle, huh?
তো এ হবে না
We have some DC power supply, so we have the reading of the voltage. So from the middle, there is some voltage reading, isn't it? If you are giving B, voltage is 0, isn't it?
Sir, C jani can answer na?
C, because it's showing you AC.
Oh, okay.
So you label it. That day I told you to label. C is showing you AC if the time base is off. Huh?
Hmm.
If time base is on, then you'll see one sine curve. Okay,
Hmm.
the wave you will get.
Hmm.
And here voltage is 0, time base is on. Okay,
Hmm.
this one D. Voltage is 0, but time base is on.
Hmm.
D. Are you labeling all?
Yes, sir.
And here B, voltage is 0, time base is on. It is for DC. This is for AC. D is for AC. Voltage is 0, time base on. B for voltage is 0, time base on for DC. And here A, we are having DC voltage. Voltage is on, but time base is off.
Hmm. Hmm.
Now I think if you are getting any sort of questions, you can answer, right?
Hmm.
Like this. Okay. Next. Anything else here in MCQ?
No, sir.
Okay. Now we will go for structured part. Huh? Did you try structured?
No,
Huh?
sir.
You did not?
No, sir.
Why? Why
Sir,
didn't
I
try?
gave up.
Huh?
I gave up
You gave up.
MCQ. Uh,
So you got frightened. Huh? Now you try. Yeah?
hmm.
In front of me, you try. Read the question, then try. Yeah? Read loudly, please.
The electromotive force EMF of a battery is 12 volts. The switch is closed. The connecting wires are in the circuit are made from copper covered by insulating plastic. State the name of the particles that flow in the copper and state the direction in which they flow at point Y in the circuit. That
Okay,
flow
so
from copper.
state the name of the particles that flow in the copper. What is flowing in the copper?
Electrons.
Electrons, yeah. And state the direction in which they are flowing at point Y. State the direction. It's going from hmm?
uh, from right to left.
Yeah, right to left. Yes. Very good. It's going from right to left. So it's easy, right?
Hmm.
Then next.
At room temperature, the resistance of component Z is 6. State the name of component Z.
What it is?
Thermistors.
Yeah, done. Then next.
Calculate the resistance of the whole circuit. Resistance of the whole circuit.
Yeah, calculate
1
the resistance.
plus 1.5 plus 1.5.
Yeah, check what is the final answer comes.
4.3.
Hmm?
4.3.
How?
Because sir, 1.3 plus 1.5 plus 1.5.
So what is the resistance of Z?
I don't know.
Is it given?
No.
Nothing is given there. They are
Oh,
saying
6.
so.
Oh, yeah. So
It's
2.8
given
plus
there,
6,
right? So
8.
6 and 1.5, they are in parallel combination, right? If it is in,
8.8.
if they are in parallel combination, then what is the formula? RP. You write this formula. RP. RP
Hmm.
equals R1 by R1 multiplied by R2 divided by R1 plus R2. Isn't it? So
Hmm.
calculate what is the value is coming.
Sir, RP এর জন্য না 1 by R1 plus 1 by R2.
Yeah, we simplified it. We simplified it to get it directly. Otherwise, after getting that, you have to reverse. Then you will get. Sometimes the students, my dear students, they forget to reverse. Then their problem becomes wrong. That's why it's better to use this formula. Okay. RP
Okay.
equals R1 R2 divided by R1 plus R2. Use this.
Hmm.
The one you said, if you simplify, it comes like this.
Sir, is it 2.5 ohm?
Total.
হ্যাঁ।
And RP is 1.2, isn't it?
Hmm.
Yes, for showing RP, you have marks. That's why you have to show it. In your working, you have to show it.
Hmm.
Is it clear to you? So use
Hmm.
this formula and do the calculation and find your RP in your worksheet. Do it. Then you show the last step, RS. RS equals 1.2 plus 1.3. That is 2.5.
Hmm.
Then calculate the current measured by the ammeter. Where is the ammeter given? Here. Okay. So you got the resistance, you got the voltage. So you can find the current, right?
Hmm.
12 by 2.5. How much it comes? Current
4.8
4.8, and the unit is,
amperes.
yeah, you should write also the unit. Never forget it. Okay. Then next, this one. Can you read 4?
The current in the ammeter is IA. The current in the 1.5 ohm resistor is IR, and the current in component Z is IZ. State write an equation that relates these three currents.
Yeah. So what should be the equation?
Is it
You
IA plus IR plus IZ?
Yes, IA equals IR plus IZ. Correct. You are right. Then next, continue, please. Read, Read this. loudly. Say.
স্যার আমি ভুলটা বলছি, আপনি কারেক্টটা শুনছেন।
Sorry?
I said the wrong one, you heard the correct one.
What you said?
I said IA plus IR plus IZ.
Oh, IA equals. IA equals. Because I R plus IZ combining, it's making IA. Isn't it?
Mm-hmm. Okay.
Yeah.
Screen of oscilloscope, trace with solid close, switch close, trace with switch open. So this set to state and explain what is observed on the oscilloscope screen as the temperature of Z increases.
Yeah. If temperature of Z increases, what will happen?
The
Before
resistance will
going to oscilloscope, you just think of normally. Yeah. But if temperature increases of Z, that is thermistor, right? Huh?
uh,
So if your temperature increases in the thermistor, then resistance will decrease.
hmm,
If resistance is decreasing here, here the resistance was 6.
hmm.
For example, now it is 4. So what will happen? RP will become less, isn't it? RP will
R
become
yes.
less. Do you agree?
Hmm.
If RP is becoming less, then you will get more voltage sharing across 1.3.
Sir, আবার
I am writing, huh? You write also. You write there, not here. Where
yes,
your question is given, there you write. If temperature increases, then resistance of Z decreases. Do you agree? Do you agree?
जी sir.
Hmm. Hence, therefore, RP, RP decreases. So, PD across, you understand PD, right?
Hmm.
PD across 1.3 increases. What I said that voltage sharing is more in 1.3.
Wait,
Is it clear now?
yes sir. One by
According to
yes,
uh, potential divider rule, across 1.3 ohm resistor, the voltage sharing will be more. So the oscilloscope will get more voltage, isn't it?
okay, Therefore, RP decreases. RP decrease হয়. So PD across 3 ohm increases.
Eventually,
Sir, PD across 1.3 ohm increases কেন?
potential divider rule. If previously the RP was bigger, right?
হ্যাঁ,
When the temperature was not increased, that time RP was bigger.
হুম,
Then RP was sharing more. We are doing comparison. Now what we are getting, previously what we are getting. We are not comparing that which one is getting more voltage, which one is getting less voltage, isn't it? We are comparing two conditions. One is with the thermistor we had no temperature increase. Now the condition is temperature increase. Is it clear?
হুম,
So the voltage shared before by 1.3 ohm, now it will be more than before, isn't it?
হ্যাঁ,
So oscilloscope will get more voltage.
okay, okay.
Is it clear?
স্যার বুঝছো?
Okay. So people are singing song or listening to the music when they are getting leisure time, right? Isn't it?
Usual.
And now it is your task when you get leisure time, then you try to resolve this type of questions. Okay, this is your music.
Weird music.
Yeah, it is your music. Okay,
Hmm.
will you do it?
Yes, when I get free time.
Yeah. If you can make it music, then you'll get world ranking. Yeah. So here, state and explain what is observed on the oscilloscope screen as the temperature of Z increases. So our answer is not done. Eh? Answer is
Hmm.
still not done. We have another point that if we have more voltage, then we will see uh, the reading we are getting here. It will go more up, right?
Hmm.
This one is the reading, right, of the voltage previous.
Hmm.
Now we'll see that oscilloscope is getting more voltage. So this line trace with switch closed will be little bit
Higher.
more higher. Yes, higher, or the reading will be more. Is it clear?
Hmm.
So write it. Trace uh, of oscilloscope will move up. Okay, is it
Hmm.
clear?
Hmm.
So you are here getting 4 points, right?
হ্যাঁ, move up. Hmm.
Now uh, if it is done, then just give me a second. I'm taking the short snipping tool. Oh, mosquito. This is O-level batch. Batch 1, 2. Yeah, I'm trying to make your resource more rich. Um, this one is question 1, right? SQ1. 1B, right?
Yes, sir. 1D.
Okay. Yeah, I saved it so that I can send it in your group. Now next part, huh? Next part, D. Your fear is going, right, Tamjid?
Yes, yes.
Okay, read.
The 12V battery is made from cells of electromotive force 1.5B, which are all in series. Calculate the number of 1.5B cells that make up the battery.
Yeah. So they are in series, right? The
So
12
is it?
volt, the 12-volt battery is made from cells which are 1.5 volt. Huh? They are in series. Calculate the number. So how many, if you connected in series, it will be 12. Alhamdulillah, excuse me.
Alhamdulillah.
Okay. So 12 volt divided by 1.5. How many check? 8, right? Or 6? Or 8? How many check?
8. 8, 8.
8. So right here
12 divided. Yeah.
12 divided by 1.5. That means 1.5 and 1.53, right? So if they are connected in parallel, what will happen? If you are connecting the cells in parallel, it will be as it is, right? I think you learned it uh, in current electricity DC circuit there.
না স্যার এটা মনে হয় আমি পাইনি
Oh, why? I gave you notes on current electricity DC circuit. It's written there. You check there. Huh? This
ওকে
note is there. If you are connected in series, what will happen? If you are connected in parallel, what will happen? It's written there in my notes. Go through, huh?
হুম
Yeah. So if you are connecting thousands of cells in parallel, it will be same. Okay, 1.5. Is
হুম
it clear? So it should be 1.5.
স্যার EMF of the battery not of the cells
Yes, if they are in parallel, it will be 1.5.
স্যার
Okay.
12 ভোল্ট কেন না
Hmm?
12 ভোল্ট
If
কেন না
if if they are connected in series, that time it is 12. Okay.
State the EMF of a battery made by connecting all these cells in parallel.
Yes, yes.
ও ওরা সেল গুলো নিছে না? আচ্ছা আচ্ছা,
Hmm.
1.5 ওহম।
Hmm. None.
জি স্যার।
Okay. So our question 1 is done, right? Question 1 is done. Now question 2. Hmm?
স্যার আমি একটু ল্যাপটপ দিয়ে জয়েন করি, 2 মিনিট।
Okay, okay, no problem. Join. Yeah. Two conditions or two requirements for there to be a continuous flow of electrons in the tube.
ক্যাথোড আর অ্যানোড।
Is it cathode is giving you supply, right? Supply of electrons. So is it enough to be only cathode, or we have filament, hot filament also? Hot metal filament also we need, right? And the one you said anode, that one should be more specific, like you can add there like a high positive potential in anode. Very high positive potential should be there, so that there is electron beam, right? It is attracted. The anode will be attracting the electron beams. Is it clear? It's written in your notes. Is written there, these two requirements. And there is also another requirement that the place where we are doing all these things, that one should be vacuum, right? That one should be vacuum. Do you have the notes in front of you?
জি স্যার।
So you check it there.
হ্যাঁ স্যার, ছবিতে একটা ভ্যাকুয়াম দিছে,
Mm-hmm.
ক্যাথোড দিছে, অ্যানোড দিছে, হিটার দিছে।
And not only in the diagram, it's written in the description. It's written also in the description. You check the requirements. There should be high positive potential, right? The anode.
রিকোয়ারমেন্ট।
Yeah.
স্যার কোথায়? আমি তো পাইলাম না।
Okay. I'm opening the notes, then we'll see it. That's why I'm opening. It's not given point wise, but in description it's written. Check. Look here. By heating the cathode in vacuum, huh? This one is one thing we have. Then look here, look. Hmm. If there were no voltage applied, the freed electrons would just form a cloud around the cathode. Huh? The
Hmm.
application of the voltage causes the electrons to stream away from the cathode in a ray of beam. Hmm. So there should be high positive potential here in the anode. Okay, is it
Hmm.
clear?
হ্যাঁ স্যার। So
So
one হচ্ছে vacuum, two হচ্ছে voltage.
yeah, high positive voltage, high positive voltage. You mention it clearly.
High positive voltage and vacuum.
Vacuum. Another one you add there is a hot filament lamp. Hot filament, hot metal filament.
Hmm.
Is it clear now?
Hmm.
Okay, so we are going to the worksheet again. So this two are done. Then B. Can you read the part B?
Microphone detects two pulses of sound. The output is displayed on a screen of an oscilloscope. Figure 2.1 shows how the voltage output of the microphone varies with time. Describe how the time between the two pulses can be determined using the display on the screen of the oscilloscope.
Okay, so this one you got right. How to calculate the time or time period. Hmm? So at the beginning, one MCQ you got MCQ one.
Hmm.
There you got this idea. Okay. So what we did there, we
Hmm.
we got the number of divisions, right? How many divisions are there?
Hmm.
Yeah. So we will find that one, and we will also get the time base. Like the time base is given, for example, 5 millisecond every division, right?
Hmm.
So
Hmm.
if there are, for example, 6 divisions, then there will be 30 millisecond between the peaks,
Hmm.
isn't it?
Hmm.
Do you understand what I'm saying?
Yes, sir.
So here for 2 marks you find that uh, first one is uh, find number of divisions between the peaks. Hmm.
Okay, wait. Sir, এক minute. একটু
Number one, find number of divisions between the peaks.
হ্যাঁ স্যার এরপর
Then number two, multiply the time base with number of divisions to get time between the peak. Between two pulses, you write, other than writing peak, you write between two pulses. Multiply time base with number of divisions to get time between the two pulses. Is it clear to you, or I should give example?
Has that example then bhalo hobe.
Okay. Like this one is shown on the oscilloscope. Okay. If it is like that, and it is like that, huh? Okay, in the oscilloscope it is like this, huh?
Squares.
Squares like this, huh? This way, this way, huh? So we will find from this peak to this peak. For example, we have 1, 2, 3, 4, 5. For example, here 4.5 divisions.
Yes.
4.5 divisions we got here. And in our time base setting, it is given how much? I told 5 millisecond per division. Okay.
Yes.
Time base is how much? You write also. Time base is how much? Time base is 5 millisecond per division. This way the time base is given. So the time between the two pulses, time between two pulses equals how much? 4.5 4.5 division multiplied 5 millisecond per division. 5 millisecond per division. Then division is cut. What is left? If you multiply 5 into 4.5, how much?
22.5.
22.5 millisecond. This is your time between two pulses. Okay? That's it.
Yes, easy আছে.
So this one we just gave here. In the description we gave in 2 steps how to do it. Now in the space below, draw the circuit symbol for a NAND gate. You know this, right? NAND gate, AND gate, OR gate. You know them?
Yes, sorry.
So if you know them, then you can do them. Now you have confidence, right?
Yes, sir.